let's take a look at this problem from the WebAssign. A race car has made a pit stop to refuel. After refueling, the car starts from rest and leaves the pit area with an acceleration whose magnitude is 5.8 meters per second squared. After 3.9 seconds, he enters the main speedway. At the same instant, another car on the speedway and traveling at a constant velocity of 68.2 meters per second overtakes and passes the entering car. The entering car maintains its acceleration. How much time is required for the entering car to catch up with the other one? So that's really the key, is that we know that the acceleration for car one is going to remain the same. So let's take a look at all that's going on. There's really three parts to this problem. So car one, we have his initial condition. So what do we know? We know that he starts from rest, VI is 0. We know his acceleration is 5.8 meters per second squared. And we know that the time is 3.9 seconds. And then we're not using it yet, but we also have this car 2. And car 2 is going at a constant velocity, so that's going to also be equal to his average velocity. And he's going at 68.2 meters per second. So we'll come back to that in a second. So going back to these initial conditions here, I can say, well, all right, how fast is the car going after it enters the speedway? So I'll say VF is equal to VI plus AT. So VF is equal to 0 plus the product of the acceleration, 5.8 meters per second squared, times the time, which is 3.9 seconds. So I did that ahead of time, 22.6 meters per second. All right, let me just check that that's correct. 5.8 times 3.9. Yeah, so 22.6 meters per second. So that's how fast he's going. So this, during the second phase, where he's on the roadway, what do they call it? The roadway or the racetrack? Speedway. On the speedway, that's his VI, 22.6 meters per second, right? And on the speedway, we know his acceleration stays the same. So his acceleration is going to be 5.8 again, meters per second squared. And we know that he catches up to the other car. So therefore, I know that his V average is going to be equal to 68.2 meters per second, right? And ultimately, I know that because the cars catch up to each other, average V1, right, average V2, that's where I got this from. So what am I looking for in this problem? I'm looking for how much time is required for these to catch up with each other. So I also know, so if the averages are the same, I also know that the distance traveled has to be the same, as well as the time. I mean, really the time's going to be the same as well. So down here, if I can use this information to find the distance, I can use that to find the time, or if I could find the time directly from here. So let's see, what formulas do I got here? can I find VF? Can I say that V average is equal to V1 plus V2 over 2, right? So if I do this, what am I going to get? 68.2 meters per second is equal to V1, which is 22.6 meters per second, plus V2 over 2. So I take the 2 to the other side. So I get 68.2 times 2. And then I'm going to subtract minus 22.6. So it looks like my final speed is I can't see that without my glasses. One 13.8. So VF is 113.8 meters per second. So he started at 22 and he accelerated up to 113.8. So now I've got VI, I've got A, and I've got VF. So now I think I can say VF is equal to VI plus AT. Remember, that's just A is equal to, it's really just this formula rewritten like this. So VF is 113.8 meters per second. VI is 22.6 meters per second plus 5.8 meters per second squared times T. So I've got to subtract that to the other side. So 113.8 minus 22.6 is that, 91.2. And I'm going to divide that by 5.8. Divided by 5.8 equals 15.7. So I think the time is going to be 15.7 seconds. And so let's look at the answer. Yeah, 15.7 seconds. So just to recap, you had to do this initial conditions in order to find out how fast he entered the speedway. And then once he was on the speedway, I can use the V average from car 2. To find VF of the initial car. So it didn't ask me the distance, but I could even go back and find the distance as well. So yeah, that's how you do that one. You have to know that the V averages are equal, which is similar to the last test we did. And then you have to know that you have to do it in 2 steps.